Hi students, welcome back. Today we are going to look at the longest substring without repeating characters problem. Let's look at the problem statement. The problem statement says we are given a string S and we have to find the length of the longest substring without repeating characters. So we have to find a substring which has all unique characters in the given string. So the given constraints are there is some constraint on the length and the type of characters it can have. It can only have English letters, digits, symbols, and spaces. Okay, so let's look at an example. So in this example, the given string is ABC, ABC, BB. Okay, so here the substring with unique characters is either this ABC or this ABC, or it could even be BCA, okay, or it could even be CAB. But all these strings are of size 3. So the output is 3. Okay, let's look at another example. If the given string has only one type of character, then the answer is obviously 1. Let's look at another example. So here the unique characters, substring with unique characters is either this one or this one. Here also both the string size is 3. Hence the answer is 3. Here we are looking at a substring, meaning it has to have consecutive characters. We can't have a subsequence, which is why the answer will still be 3. Okay, so let's look at the algorithm to solve this with an example. Okay, let's take the same example. P W W K E W. Okay, now let's take two pointers, start and end. Okay, let's say this is start, this is end. Okay, and let's take another pointer called start. Okay, let's consider this start. Now what we will do is we will keep advancing end until we find uh, a repeating character. Okay, so end will keep forwarding as long as the characters are unique. Once we find a repeating character, that means the string between start and end is not unique anymore. So at that point, what we will do is we will advance start until we make this substring between start and end unique. So what we need is we need a data structure to keep track of the characters in the string. Let's take a hash map because it's easy to uh, find the existence of a character in hash map. We can do it in order of one. Okay, and we also have to keep track of the max count. Okay, let's call this count. So initially start and end are at the same place. Okay, so the count would be 1. Okay, now the next, and we also have to add this character to the hash map. So let's add P. Okay, let's add it with its current location. Okay, so this will be useful later. I'll tell you how. Now, um, and let's advance it to its next location. So now end will come to W. Okay, is W unique? W is not in the hash map. So W is also unique. So let's add W to the hash map and let's continue. Now we encountered another W. Is W unique now? No, it is not. We can see that hash map already has a W. So at this point, to make the string between start and end, what we will do is we will advance start to the last known location of the repeating character, which is 1 plus 1. Okay, so in this string PWW, our repeating character is W. Okay, as long as a start to end string has that previous W, it won't be unique. So we have to move to a character after the last known location of that, which is why start should move till here. Okay. Oh, in between we forgot to update the count. So when we were at first W, the count will become 2. Okay. Now start and end are again for pointing to the same character. Again, the last known location of this character now will change to 2. Okay. So start and end are pointing to the same character, which means length is 1. So we don't have to update count in this case because so far in PWW, the maximum length we have seen is 2. So there is no point reducing it because this count is actually keeping track of the max length. Okay. Now let's continue the process. Now let's advance our end pointer. Is K unique? Yes. Okay. Let's add K to the hash map. Okay. So K is at location 3. Okay. The next character is E. Is U unique? Yes. Let's add E to the hash map. Okay. So when we were at K, that is when we were at here, so the length of the substring is WK, correct? Which is same as 2. So we don't have to update this count. Now when we are at E, the length of the substring is WKE, which is 3. So we have to update this count now. Okay. Now start to end, our string is unique. We don't have to do anything. Now, when we are at W, W is already present. Okay. So, what will we do? We will advance start to last known location of W, which is 2 plus 1, which means start will come to 3, which is this point. Okay. Start will come here. Now, when start is at here, what is the location of string? Length of the string? 3, because the end is here and start is here. So, the length of the string is 3. Since our current string is already 3, we don't have to update this count. Okay. Now, one thing left to do is we have to update the last known location of W. Now, this will become 5. Okay. Now, beyond this, we have reached end of the string, so we don't have to do anything. And by this algorithm, our maximum longest substring is 3. So, the simple technique here is you are taking 2 pointers to keep track of the substring. So, the 2 pointers hold start and end of the string. So, at any point, your goal is to keep the substring in the range of start to end as unique substring and keep updating the count to if it has found any bigger one. Okay. And we will keep advancing end. How long will we advance? As long as we find unique characters, we will keep advancing, because in that case, between start to end, it will be unique. Now, when we find a repeated character, okay, what we will do is we will change start to the last location of that repeated character plus 1, so that the string between start and end is still with unique characters. Okay. So at every point, start to end is having a substring with unique characters, and we will keep updating the count to reflect the maximum size. Okay. Let's write code for this. So we are given a string S. First, let's convert it to a character array. Let's call it char string. Okay. And we also need a hash map. So let's initialize a hash map. I'm just calling it map. Okay. This hash map will hold the character and its location. That is why it is a map of character and integer. We also need to keep track of the max count. So let's keep a counter for it. Initially, the size is 0, which is why we will call it count 0. Okay. Now let's take a for loop from so start and end. So initially, as we discussed in the algorithm, they will be at 0th location, and we will keep advancing end, which is why we are doing only end plus plus. Start will change based on our last known location, which is why we are not doing start plus plus. So end is our index traversal one. So at this point, let's get the current character. What is the current character? Char string of end. Okay. Now, if our map contains this character, we have a different logic to follow. So, if our map contains this, we will update start to this the current location of the character plus 1. Okay. Or we have to keep it at the current start. So we have to do a math.max here. That is because if we don't do this, we might even go back in history. We only want to see in the last seen ranges. Okay, that is why we have to do math.max here. So for this, if you don't do this, try with this example, it will fail. Okay, just try the dry run with that example and without doing math.max, then you will understand why we have to take a max of start and this one. Okay, so now we have the new location of start if the map contains. That means if there is a repeating character. If that is not the case, or in general, what we have to do is we have to update map with the current location of the character. Okay, and we also have to keep track of the max count always. Okay, max count is n minus start plus 1. Okay, so in this step, we are at every point we are calculating the size of the string between start and end, and we are just taking the maximum because we are only interested in maximum substring. At this point, we are updating the location of the current scene string in our map. Here, if we see a repeated character, we have to move start, which that is taken care in this step. Okay, so let's run it and see. Yeah, so let's submit it. So what is the time complexity of this thing? We are traversing the entire string only once, so it is order of 1. What is the space complexity? We are taking an extra hash map. It doesn't take the size of the string, but it takes whatever the unique characters we have, which is alphabets, digits, spaces, and symbols. So whatever it is, it will still be a constant. Okay. So that's all we have for this problem. Thank you for watching. If you have any questions, please do leave a comment. Please like, share, and subscribe. Thank you.